You know, forget faster chips for a second. Forget bigger and bigger models. Today, we're going to talk about something completely different, a really radical idea that could totally reframe how we think about artificial intelligence. What if an AI could perceive reality not through endless data, but through the very fabric of physics itself? So, just chew on this for a minute. What if an AI could learn, not by crunching numbers, but by achieving a kind of harmony with the universe's physical laws? This is the wild idea at the heart of a huge paradigm shift called resonance-first computing.
Okay, so let's dive in. A really great way to get a handle on this is to picture AI as having two brain hemispheres. The left brain, that's the traditional AI we all know. It's logical, it's symbolic, it's built on pure digital computation. But now imagine a new right brain. That's resonance-first computing. It's intuitive, it's physical, and it operates on these continuous analog waves.
To really get how this works, we have to look at the absolute most fundamental building blocks. I'm talking about how each of these brains sees the world, and that difference starts with the smallest possible unit of information. For a standard deep learning model we use today, a bird isn't really a bird, you know? It's not a physical thing made of flesh and feathers. It's just a grid of pixels, a big collection of abstract numbers that are statistically likely to be connected to the label bird. The actual physical reality just gets lost in translation. And at the very heart of this is the classical bit, the 0 or the 1. It's the foundation of our entire digital world. But here's the thing. It's a total abstraction. It's just a symbol that has absolutely no inherent connection to the physical world it's trying to describe. Now, in complete contrast, resonance-first computing uses what's called the arbit. An arbit isn't a symbol at all. It's a physical mode of vibration. Think of it like a real wave in the world, with a specific frequency, a specific amplitude, and a phase. Its information is literally grounded in physical reality from the get-go. And this table, it just lays out the difference perfectly. On one side, you have digital logic, manipulating abstract bits. And on the other, you have physical wave interactions, things like resonance and interference, actually doing the work. One is simulating reality with numbers. The other is computing as a part of reality itself. So if their building blocks are that different, how in the world do these two brains actually learn? Well, it probably won't surprise you to hear their methods are worlds apart. One is basically chasing numbers, while the other is looking for harmony. Traditional AI, right, it learns through this kind of brute force error correction. It makes a guess, it calculates a numerical score for how wrong it was, that's the loss, and then it adjusts its internal numbers over and over and over again, literally millions of times, just to get that error score a tiny bit lower. Resonance-first computing just throws that whole idea out the window. Learning isn't about getting a better score on some task. It's about the system physically organizing itself to achieve a state of harmony, to reduce these messy inconsistencies with the physical world. Okay, so this is the crucial point. Get this. Traditional AI is trying to minimize task error to get the right answer on a test. But RFC is trying to minimize law error. It's trying to make its own internal state physically consistent with the universe. And it does this using something called the physics of physics operator, or POP. Think of it like a universal fact checker that's constantly nudging the system, making sure it doesn't violate basic physical truths like gravity.
Now, you can probably guess where this is going. This profound difference in how they learn leads to a completely different idea of what meaning even is. Is meaning just a pattern in the data, or is it a pattern in reality itself?
For deep learning, meaning is really just a statistical approximation. The word cat means a pattern of pixels that shows up a lot with that label. But for resonance-first computing, meaning is a persistent, stable resonance. It's a physically coherent pattern that's in harmony with the laws of nature. It's real. And that disconnect in traditional AI, well, it creates what's called the embodiment gap. Its internal ideas are ultimately just symbols, totally divorced from the physical world that created the data in the first place. It knows the word gravity, but it doesn't feel its pull. RFC is built from the ground up to close this gap. It doesn't process abstract data from different sensors in separate pipelines. No, its internal resonant fields physically synchronize with external energy fields, whether that's light or sound or even gravity. It creates this one unified,
multimodal perception of the world.
So where is all of this going? What does it all mean? Well, it's pointing towards something that feels a lot less like a computer program and a lot more like a new form of, well, living, physically grounded intelligence.
And we're not just talking about some new software running on a GPU. We are talking about entirely new hardware, resonance processing units, or RPUs, RPAs. These are actual photonic chips that compute using the physical interference of light waves. Just think about that for a second. In this kind of machine, thought literally travels at the speed of light.
And this kind of hardware, man, it unlocks these abilities that just sound like science fiction. In robotics, it could mean a car that sees through dense fog by just switching from visible light to radar seamlessly. In medicine, an AI that natively fuses X-ray, MRI, and ultrasound data into one picture to spot things that are invisible to any single view. Or even an AI that sees the world like a bee does, perceiving the hidden ultraviolet patterns on a flower that we can't see at all.
And that's really the ultimate vision here. An AI where the very process of thinking is about bringing its internal state into coherent resonance with the physical universe. It wouldn't just be simulating reality anymore. It would be living within its physical truths.
And so that leaves us with this final kind of provocative thought. If a machine's internal cognition is bound by the exact same physical laws that govern the stars and the atoms, at what point does that line between artificial and natural intelligence just dissolve? What does it mean for a thought to be as real as a wave in the ocean?